Let's look at this example. We want to find the limit of this function 7x cubed minus 5x squared plus x minus 17 divided by 4x cubed plus 8x squared minus 6x plus 1 as x tends to infinity. Alright? Now, if you should substitute directly, direct substitution would give you infinity divided by infinity. Because you have infinity cube is infinity, and 7 by infinity is infinity, minus infinity plus infinity minus 17. So up here would be infinity. And of course, infinity cube is infinity, and 4 by infinity is infinity. Plus 8 times infinity squared minus 6 times infinity plus 1. So infinity over infinity. Now, let's not use L'Hopital's rule yet. Let's try to use another method, right, to find the limit. Suppose you divide by x cubed. You divide both numerator and denominator by x cubed. What would happen? You look at the limit as x tends to infinity. And by the way, remember, when you divide by the numerator and the denominator, it's like multiplying by 1. If you divide by x cubed, it's like multiplying by 1 over x cubed. But you also would multiply the denominator by 1 over x cubed. But guess what? 1 over x cubed cancels 1 over x cubed. So it's same as it's as if you're dividing or multiplying the entire thing by 1. Alright? So the value remains the same. So have a fraction. Just like when you work out common denominators, you can always multiply the numerator and the denominator by the same number, and the value of the fraction remains. You can divide the numerator and denominator by the same number, and the value of the fraction remains. Alright? So let's divide by the highest power of x, which is x cubed. So here, let's divide each term by x cubed. You have 7x cubed over x cubed minus 5x squared over x cubed plus x over x cubed minus 17 over x cubed. Alright. And you have 4x cubed divided by x cubed plus 8x squared divided by x cubed minus 6x divided by x cubed plus 1 divided by x cubed. Good. So we have that. So let's simplify. That's equal to the limit as x tends to infinity of 7x cubed over x cubed. Same as 7. It's just 7. Alright? So it's 7 minus 5x squared over x cubed. It's the same as 5 over x minus 5 over x plus x over x cubed. Same as 1 over x squared, right? So it's, was it plus or minus again? Plus 1 over x squared plus 1 over x squared. Then out here, 17 over x cubed. Nothing changes there, right? It's minus 17 over x cubed. So that's what you have there, right? Over 4x cubed over x cubed is a 4. So that is 4. Then 8x squared over x cubed, that's going to be 8 over x. So it's plus 8 divided by x. Alright? Minus 6x over x cubed is 6 over x squared. So you minus 6 over x squared plus 1 over x cubed. Alright. Now remember, x is approaching infinity. So what happened? All of this is equal to 7 minus 5 over infinity. Now 5 over extremely large number and infinitely large number is 0. Plus 1 over infinity squared is 1 over infinity, which is 0, minus 17 over infinity cubed. 17 over infinity, which is 0. divided by 4 plus 8 over infinity is 0 minus 6 over infinity squared is 0 plus 1 over infinity cube is 0. So it all boils down to 7 over 4. 7/4, 7/4. You see that? Alright. Now, let us now use L'Hopital's rule and see if we get 7 divided by 4 again. Right? Let's copy and don't combine this thing here into one function and move it down and use L'Hopital's rule on it. Now, L'Hopital's rule. This is equal to the limit as x approaches infinity of, differentiate the numerator, 3/7 21 x squared minus 5/2 10x plus, differentiate x you get 1 minus 17. When you differentiate the constant 17 you get 0 over 3/4 12x squared plus 8/2 16x minus 6. When you differentiate 1 you get 0. Alright, when you put infinity there, you would have infinity over infinity. Now, still indeterminate, so you continue. This is equal to the limit as x tends to infinity of, differentiate again. So what you have? 2 times 21 is 42. X minus, differentiate 10x, you get 10 over 2 12 24x plus, differentiate 16x, you get 16. Alright. Now, here, you end up with infinity over infinity again. So, what you do? You differentiate again. So, what you have is, this is equal to the limit as x tends to infinity of, now, differentiate, you get 42 over 24. 42 divided by 24 is going to be 24 2. Let's see if we can divide down. 2 into 42 goes what? 24 2, 2 into 2, 1 over 2 into 24, 12. What is, you can divide down by 3. 3 into 21 goes 7. 3 into 12 goes 4. 7 over 12. So you get the same, 7 over 4. So you get the same 7 over 4, right? Using L'Hopital's rule. So, this is another one that shows that when you have a function divided by another function, you should find the limit as x tends to a number. And if you get the 0 over 0 or infinity over infinity, L'Hopital's rule can be used on it. Alright? So, I'll see you in the next video.